Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VGSO IIT Kharagpur who is taking this course, and we are in week 5 and we are discussing about pricing. So, in this whole week we will discuss about pricing in great details, and in this particular class we will discuss about power block pricing. So, power block pricing is the pricing that generally the power companies, the electricity companies generally try to use. So, even there also you will see that the demand of electricity will be dependent on the price. As price goes up, the demand comes down. But electricity companies has to decide that there are various time periods from at which the prices will be different, and probably there are various kinds of users for whom prices will be different. The charges for domestic users and the charges for probably the industry users should be different. So, all of these things comes into this picture, and we try to, and then there are certain costs which are fixed. For example, let us say if I am pretty sure you know that let us say you have went out from your home for a very long time, let us say probably 2 months, 3 months, you still have to pay a little bit of money for the electricity, probably for the meter that is there, or some basic base price you have to pay. So, there are that is also one type of pricing where you have to pay some amount of price which is base, and after that for every additional usage of electricity you will actually pay more. So, all of these things comes under the power block pricing, and we will discuss about that particular strategies, various strategies that one can adopt in to take care of power block strategy in details. So, in this particular class we will talk about basically 4 ways, and this is the very basic one, the starting one which we start with. So, let us say I have from the past data I find out that demand is a function of price, and the formula that is written is demand is equal to 20 minus 4 price. So, if D is equal to 20 minus 4 price, then basically I can write 4P is equal to 20 minus D, and I can also write P is equal to basically 20 minus D by 4, which comes around 5 minus 0.25 P, and that is what is probably written here, that I can also write price as a function of demand instead of demand as a function of price. So, both ways I can write that. And why that? What is the second line mean? Actually, does the price is affected by the demand? It is actually sometimes affected by the demand. As demand goes up, if the supply is constant, then the price will also go up. So, you will know that the equilibrium will come, and both demand and price can actually impact each other. Another thing where this cyclical relationship, other than the cyclical relationship, another thing which we want to say by saying this, the last line is probably this price can also be used as willingness to pay of the customers, of the last customer. So, if the demand is X, so let us say according to this formula, the demand is let us say by any chance the demand is let us say 4. Then the last customer who has the lowest willingness to pay, the willingness to pay for the last customer will be 5 minus 0.25 into 4 comes up to be around 4, 5 minus 1 which is 4. So, that is where also this particular equation comes in handy, and we will use this equation to solve certain problem which is related to willingness to pay as well. So, now before I go ahead and do all those stuff, the first thing that I want to focus on is what happens when there is a normal pricing. There is nothing extra excessive thing that is there, it is a normal pricing. So, I have written price, demand, cost and profit. Price, let us say I set the price as 3 rupees. So, if the price is 3 rupees, what will be the demand? $3 in this case. What will be the demand? Demand is basically 20 minus 4 into price. So, that is the formula that has been written there, 20 minus 4 into D8 by D8, because D8 is where the price is written, the $3 is written there. So, 20 minus 4 into 3 comes up to be 20 minus 12, that means 8. 8 is my demand. And I am assuming that the unit cost is $2. So, let us say this is the situation that has been given, that the demand function is given $2 unit cost is given. What is the maximum profit that you can make out of it? You can make profit as, carefully see, D9. D9 is what? D9 is the demand part. D9 into D8 minus D10. What is D8? D8 is the price and minus unit cost. So, this formula comes up to be like this, that your profit is basically demand into the revenue minus the price. So, that comes up to be, the demand into price minus the unit cost, that comes up to be your profit. Now, I have to do something to maximize this profit. So, I can write it in a formal way also. So, I can write it like this, that okay. So, my profit is basically D into P minus C, where C is the unit cost and D is also a function of P. So, basically P minus C. So, this I can find out for which P this becomes 0 and this becomes negative. I can solve that. So, in a previous class we have seen that this can be solved using solver in your Excel file. So, I will also use solver in my Excel to solve this thing. So, I will go to this and I will go to data, and there is a solver button. In a previous video I have shown you, if this particular button is not there, what to do to get this button. So, I will click on this one, and when I click on this one, so it is asking me that which one I will want to optimize. So, I will want to optimize D12 by changing, so maximize D12 by changing what? By changing my price. So, by changing D8, and D8 is greater than 0, this you can probably delete and make the unconstrained variables non-negative, that is enough. So, if you just select that and GRG nonlinear, because it is nonlinear function, try to solve it, you will get a solution, and the solution is saying that $3.5 is the optimal price in this particular case, and the profit in this particular case you are getting is $9, because there will be 6 people who will be buying it. Your unit cost is $2. So, 3.5 minus $2 comes up to be $1.5, and then for $1.5 into 6 is your demand, 1.5 is your unit margin actually. So, 1.5 into 6 comes up to be $9. So, that is something that you generate when you are doing a profit maximization, and you can set up only one single price. But in real life situation, as I told, that you can actually set up multiple levels of pricing. So, you can say that in our in some of the places where I stayed, it was 0 to 100 units some price, 100 to 150 units some other price, 150 to 200 units some other unit price, and that actually is dependent on how much is the willingness to pay of those people who actually consume up to that level. So, they keep on a tap on, so keep on actually doing surveys or some things, and they say that this demand curve that you have put is not always a linear curve, it can be a broken linear. But even if it is linear, even if they are one single line that defines the demand curve, still we can have prices at different levels, and that is something that we will talk about right now. So, in this particular thing, we have suggested that there are two types of price. So, let us say the high price and low price defined as HP and LP in this particular graph, HP and LP, and the cutoff is something. So, people who are below this cutoff has to pay. So, up to this cutoff the charges is $3, and after this cutoff the charges is, let us say $6, or I will write 5 or 2, let us say 5 or $2. Now, what is the situation that I have to find out? So, this is something that I have to decide. My decision variables are 3 points. My decision variables are basically 3 numbers. The first number is what will be the cutoff. Then the second decision is how much price, how much unit price below the cutoff and how much unit price above the cutoff. So, this is basically the decision variable that we are trying to find out. So, you have to decide a cutoff value up to a level, and now I am talking about two price ranges. There can be multiple price ranges. There can be low price, medium price and high price. With the same demand curve, you can try to find out that when the usage is between $0 to $5 one pricing, $5 to $10 another pricing and $10 to $15 another pricing. So, I will try to do that in this particular session itself. I will try to do that. So, let us say right now I have been told that I can only have two particular cutoff, one particular cutoff, and there will be two prices, high price and low price. Now, remember that this thing, that this particular it's a electricity, and electricity is measured in units. So, 1 unit, 2 unit and so on. So, these are the units that has been consumed, the demand. So, 1 demand, 2 demand and etc. And because we are trying to do trying to actually focus on the on a continuous variable, in here in this particular equation, my demand is equal to 20 minus 4 into price. The assumption is that the demand is a continuous variable. So, because the assumption is that the demand is a continuous variable, we have changed this unit, 1 unit consumption, 2 unit consumption to a continuous variable. So, 1 is basically 0 and 1's mean, which is 0.5, 2 is 1 and 2's means, which is 1.5 and so on, and I have till 20 I have taken. So, till 20 units you can actually have in a real life situation, it will be up to probably 100 units or something like that, or if the measurement of unit is different, then things will be different. But let us say we are doing it for up to 20 units, we think that most of the people will actually purchase below 20 unit. Remember another thing is that, so if the price is 0, if the price is 0, the maximum possible demand is 20. You cannot, according to this particular equation, the demand cannot be higher than 20 in a practical situation, because otherwise the price has to be negative. That means somebody uses and you are paying him money, which is not possible. So, when the price is 0, demand is 20. So, that is why we have taken up to 20. Now, what is the value thing? The value is the willingness to pay. So, this is something that we remember in the bundling case we did this thing. So, that whenever your price, your willingness to pay is higher than your price. So, let us say you have two options, and option 1 and option 2, and you will choose option 1 over option 2 only when V1 minus P1 is greater than V2 minus P2. You will only then you will choose this option 1, where VI's are value and PI's are price. Now, VI, if I change it to this value, if I change it to the monetary term, we can also say this is the willingness to pay, how much money you are willing to pay. That is also a proxy of value, and you will choose this one over this one only when this happens. So, this is something, it is a basic thing, and if you have 3 options or multiple options, whichever has VI minus PI maximum, if you have multiple options, you will maximize based on I, VI minus PI. So, that is the same thing that we are going to do here. So, if you check carefully, this is the value. What does it come from? The formula is 5 minus 0.25 into C6. And what is the C6? C6 is the midpoint demand. So, a continuous variable which is representing the demand of electricity. 5 minus 0.25 into C6 gives me the value. What is value? Value is nothing but the willingness to pay. The formula for the corresponding thing is this. This is what we are using there as well. So, 5 minus 25 5 minus 0.25 into C6, and then I am dragging that up. So, I am getting the same thing for all of them. Now, what is the cumulative value? So, if somebody consumes, carefully you see that if somebody, when I consume only 1 unit, this is the money that I am willing to pay. When I am actually consuming 2 units, for the last unit, for the second unit, the second person, so let us say there are 2, each person is actually consuming 1 unit, let us assume. Then the first person is willing to pay 4.875, the second person is willing to pay 4.625. In other words, if the same person is actually using both the units, then for the first unit he is willing to pay 4.875. For second unit he is willing to pay 4.625. For the third unit, so it will slowly come down how much I am willing to pay for 1 extra. It is like, let us say you have been offered let us say 1 sweet. So, I am a Bengali, so I will say 1 rasgulla. So, you have been offered 1 rasgulla, I will probably pay 10 rupees for that 1 rasgulla. You give me another rasgulla, I will probably want to pay a little bit less. Now, I have already have the sweet taste on my mouth, so I will pay another 7 rupees. But if you keep on giving me rasgullas, for the 5th, 7th, 9th one, I am already stuffed. So, I am not willing to pay the unit price for the extra rasgulla will not be much higher, will not be like the first one where I paid 10 rupees per rasgulla. So, similarly here the unit cost is coming down, the unit price that you are willing to pay for 1 extra unit of consumption is coming down. So, then how much you are willing to pay for 2 units? That is nothing but this is the first unit and this is the second unit. The summation of these two comes up to be 9.5. So, 9.5 is the cumulative value up to second unit. Similarly, 13.85 is 9.5 plus 4.375. That is the cumulative one. So, which is nothing but this cell 9.5 cell plus 4.375 cell, these two cells together, that is the cumulative price you are willing to pay when you are consuming up to 3 units, and you go on doing that till this thing. So, this is your basically the willingness to pay based on the demand function that is given. Now, how much is the price? I told let us say the cutoff is let us say 5. Let us assume that the cutoff is 5. So, if the cutoff is 5, then up to 5 units you will pay $2 per unit. So, 5 into 2 $10 up to 5th unit, and then after that you will pay $5 per unit. So, that is what is written here. So, when D6 carefully 6 when D6, that means the unit consumed is less than F1, F1 means the cutoff value. When the consumption is less than the cutoff value, how much you pay? You pay actually F2, F2 is the high price. Okay, so, for here it is the other way, for if we are doing it in the other way, for lower consumption you will pay more, for higher consumption you will pay less obviously. So, for lower consumption F2, which is not the case for many the domestic consumption. In domestic consumption, as you go up the charges, the unit prices also go up, and that is because there are supply chain issues there, how the transmission happens and etc. are different there. But in common situations, always in all common situations, let us say in the industrial situation etc., the consumption goes up, your unit prices come down. So, initially your unit prices will be high up to the cutoff. So, I did it wrong actually initially. So, F2 is the high price into D6, D6 is how much? D6 is the consumption. So, this much is the money that you pay till your D6 is less than F1, that means till your consumption is less than the cutoff. Now, when it is higher than the cutoff, then what do you pay? So, let us say it is higher than the cutoff, then up to the cutoff you will pay the high price, that is why F2 into F1, F2 is the high price into F1. So, if you have consumed 7 units, then 5 into 5 high price, 5 is your cutoff into 5 is your high price. So, 5 into 5 plus the rest 2 units which is above the cutoff, for that you will pay 2 rupees. So, F3 which is the 2 rupees or $2 into D6 minus F1 which is the extra that is above the cutoff. So, this is something that I have written. Carefully you see once more, when D6 is smaller than F1 till my consumption is less than my cutoff value, I will pay high price for each consumption. So, high price is basically F2. So, that is why D6 into F2 into D6 is my overall payment. But if by chance it is higher than the cutoff value, then what will I pay? If it is higher than the cutoff value, then up to the cutoff value I will pay the high price, but anything extra I will pay the low price. So, up to the cutoff, that means up to F1 I will pay F2, that is why F2 into F1, plus for the rest of the things means what? D6 minus F1, for the rest of the things I will pay F3. So, this is something that I have written and I have actually did it for him. Now, what is the surplus? My surplus is basically the V minus P, Vi minus Pi, so this minus this is my surplus. So, I have to make sure that I have to check that whether the surplus is positive at some point. Yes, so surplus are positive in some point. So, there are some choices which the customers can make. Okay, so I will put it here. Okay, there are some choices where the customers can be there and they can make certain choices here. So, now you will see carefully that there are some choices where it is positive and I have to find out of these which one is maximum. So, if you check the formula, it is saying that if maximum of H6 to H25 is greater than 0, then put the maximum. By chance if everything is negative, put 0. That is something that is meant. So, the maximum surplus is 3 and how much is the value for corresponding to 3? 12 unit. So, you will see this one. How did I get? I did a match. So, if H4 is greater than 0, by chance this particular maximum surplus is greater than 0, match H4 in this particular in the particular column, otherwise give me 0. So, when this maximum surplus is 0, the units bought is also 0. When maximum surplus is positive, match at what unit it is being purchased. So, 12 units is being purchased. What is the revenue for this 12 unit? That is basically you can say we look up this value into this cell and fourth column and match type is equal to false, that means exact match. So, how much money I am paying? I am searching I1 which is 12 into this red or pink, I would say pink box in the first column of the pink box, corresponding to 12 I am paying $39. So, that $39 is coming here. What is the product cost? The product cost is units bought into the cost which is $2. So, how much is the profit? My profit is basically this minus the production cost. This is my profit. Now, I have to find out. So, now see, this is my output, net output is $15 and this is my. Now, if I change the cutoff to 6, this value changes. So, this value becomes 0 NA. Actually, I have to write it carefully. So, if this is greater than 0, then only all of these things happens, otherwise it is 0 and then the production cost is also 0 and the profit is also 0. By chance if the cutoff is 4, then I get some value, if the cutoff is 3, I get some value. So, I can change it. So, I can change my these 3 cells and that will change my profit. So, this is something that I have to do. Now, what will I do? I will run a solver. So, in the running a solver, there are certain constants that has been given, carefully check. So, I have set my objective function this one and I am maximizing this one by changing these 3 cells. Now, F1 to F3. So, F1, what is the minimum value of F1? The minimum value of F1 is, so how did I put this? we have done this before or not. So, first of all, just 1 minute. So, I will reset everything. So, okay, I am maximizing this one by changing the 3 values such that these 3 values has to be lower than 20. Let us say I say the price is lower than 20. So, all these 3 values are lower than 20. Okay. And what else? This value is basically greater than 1, add, and these 2 values are basically greater than, I mean to say 0, add, and let us say I take these 2 value as integer, add, anything else. So, f1 to f3 has to be between 0 to 20 and this has to be integer, and that is okay, I think. And the high price has to be higher than the low price, that is also important. So, I will put that. So, another thing is that this high price has to be greater than equal to the low price. Okay. So, if I just check this and if I try to run this one, evolutionary is the method that I have chosen, because here in this thing evolutionary is the method that I have chosen, because there are lots of I would say lots of integer programming involved here. There are also ifs. Whenever you say if this is happening or that is happening, that is there in your calculation, you should use evolutionary. So, I am running solve and it is running. Evolutionary method takes some time in running this thing, and it will try to solve and try to find out the best possible solution based on the optimization functions of integer programming. So, we are not going into the details of integer programming and etc., but it will do a little bit of that to find out that which particular option is best, and we have chosen HP and LP to be integer. So, that is also something that will be taken care of. It is currently running, it might run for a minute or so and it will give you a result. At any point of time, if you want to stop it, so you can below you can see that the objective sale is $18 and it is not moving much, but it is still trying. In a real life situation, in bigger problem, you will see that that might move after 1 minute or 2 minutes and etc. But any point of time, if you want to stop, you can press an escape and it will give you the solution that it has find out up to that point, up to that moment it has find out whatever, it will give you that. So, I can still continue. If you do not want to stop, you can continue, or there are limits that you can set when you actually run this kind of optimization function. There is a limit that can set. So, solver cannot improve the solution anymore. So, I am saying okay, and it is saying that this should be the price, the dollar they got is $18. So, now I want to just show you this one, that is when you are doing price maximization, profit maximization with one single price, you are getting $9. When you are doing it with 2 possible prices, you are actually charging less for certain point people. So, $3.5 is the price here, and here $6 is the initial price and $2 is later price. So, you are for high users you are charging low and you are getting more money. So, that is something that becomes important here, which we have to focus on. So, another thing that I would look here is this is almost very close to 0. So, that might be something which we have to take care of. So, ideally I would run this once more, let us say 5, 6 and 2, or let us say 3, 6 and 2, this is where I will start, and in the solver thing I will not say f2, f3 as integer, I will change this and say all of these things are integer, then things gets a little bit more good, because putting a cutoff 4.9998 is practically not possible. So, this has to be a integer. So, okay. So, f1 to f2 integer, and now I try to solve it. So, it is solving, is quickly solving once more. See, $17 is where it got fixed, and I can actually stop it right now. So, I can put an escape, you will try out later point of time. It is saying 119.2, and I think I can continue a little bit, you can get better solutions out of it. 119.2 is not such a good option, you can actually get better solutions if you go on and running. So, again escape, let us say. So, okay, 119 and 2 is the solution that I currently have got. So, you put a $19 and $2, and you can find out some other options if you change if the demand curve are different. So, that is something that I am trying to say. When the prices, we have two prices, high price and low price, and you can charge high price when the charges are when the consumption is low, and you can charge low price when the consumption is right. So, keep on going and see what it actually converges at the end. I think it will converge in whatever values it is showing right now, and we will continue on this particular discussion in our next video. So, thank you for being with me in this particular video. I will meet you in the next video. Thank you.